Okay, for what we have in number 37, we have a 400-gallon tank that initially contains 100 gallons of brine, which holds 50 pounds of salt. And we have brine containing 1 pound of salt per gallon enters the tank at the rate of 5 gallons per second, and the well-mixed brine in the tank flows out at the rate of 3 gallons per second. And it's asking how much salt will be in the tank whenever it is full of brine. Okay, so again, so you're starting out, okay, with 100 gallons of solution inside of this 400-gallon tank. And now again, so we're looking at the concentration of salt. Okay, so we have X is equal to the amount of salt and for the varying level of concentration of salt, okay, so we have dx over dt, the change in the amount of salt as time changes, is equal to what we have going in minus what we have going out. And for what we have going in, okay, in terms of the flow rate, okay, we have 5 gallons of solution per second. And for what is going in terms of the concentration of salt, okay, we have 1 pound of salt per gallon. And applying the units cancellation. Okay, so for what we have going in, we have 5 pounds of salt per second. Now for what is going out, now the flow rate we have at 3 gallons per second. And again, the amount of salt is going to be changing. So you have X number of pounds of salt. Now, for what we have in terms of the volume of what is inside, I'll give you a big picture here. So we're starting out with 100 gallons. And what's happening here is that we're going to have adding 5 gallons per second in minus 3 gallons per second out times the amount of time and referencing what we have here. Okay, so we got 100 gallons plus 5 gallons per second minus 3 gallons per second times the amount of time. And now the tank will be full whenever the solution gets to 400 gallons. So right now we have what's going to be 100 gallons plus 2t, which is also going to be in gallons. Is equal to 400 gallons. So we have solution wise. Okay. Now for what we're going to have in the denominator, we have 100 plus 2t. Now by the time that the tank is full, we have 2t is equal to 300. And the tank is going to be full at 150 seconds. And just going back to the setup. Okay. So for what we have going out, okay, so we're going to have, again, so 100 plus 5 minus 3 quantity times T. Again, you have the number of gallons. And for the units, okay, we have gallons will go out. So we have 3x pounds of salt all over 100 plus 2t number of seconds. And for what we have in the arrangement, okay, so just shift over. So again, we have a dx over dt. You have in minus out. So we say we have 5 for the number of pounds of salt per second, and we have minus 3 all over 100 plus 2t times x. So we have a first order linear differential equation with x as the dependent variable and t the independent. So in the rewrite, putting in standard form, so we have dx over dt plus 3 all over 100 plus 2t. Then we have times x. And we have is equal to 5. Now, in establishing the integrating factor, now for p of t, we have 3 over 100 plus 2t, and establishing the integrating factor, so we have e to the integral of 3 all over 100 plus 2t dt. And let me mention something here. Okay, so you got 3 over 100 plus 2t. And if I integrate, so you have 3 over 100 plus 2t dt. And what I'm going to do here is I'm just going to factor out the 3 from the top, 2 from the denominator, and say that I have 3 halves of the integral of dt over 50 plus t so that is going to be 3 halves of the natural logarithm of the quantity of 50 plus t. So transferring back, so we have e to the 3 halves of the natural logarithm of the quantity of 50 plus t. And again, if I make the 3 halves into an exponent, so we'll have for the integrating factor, we'll come out to the quantity of 50 plus t raised to the 3 halves, multiplying both sides, okay, by the integrating factor. So we have, again, the quantity of 50 plus t raised to the 3 halves, again, we have multiplying by the terms on the left-hand side of the equation. And again, do not worry about distributing. And And again, we have is equal to 5. And we have times the quantity of 50 plus t raised to the 3 halves. So for what we have on the left-hand side, okay, regardless of whether I distribute or not, left-hand side, okay, we'll have the terms to end up being the product rule expansion of taking the integrating factor, which we have with a quantity of 50 plus t, raised to the 3 halves, times the dependent variable, which we have nx. And we have 5 times the quantity of 50 plus t raised to the 3 halves, and taking care of the derivative. So if I integrate over both sides with respect to t, so I have the quantity of 50 plus t raised to the 3 halves multiplied by x, and that is going to be equal to the integral of 5 times the quantity 50 plus t raised to the 3 halves dt So again, I have 50 plus t raised to the 3 halves times x, and for what I have on the right hand side, so the integral of 50 plus t to the 3 halves, okay, we're going to have 2/5 of 50 plus t to the 5 halves, and 5 will be multiplied again by 2/5, so that's going to be 2 times the quantity of 50 plus t to the 5 halves plus c, and isolating x, once I multiply by 50 plus t to the negative 3 halves, or divide by 50 plus t to the 3 halves, and we have 2 times the quantity of 50 plus t. And by then, this is going to be a first order. And we say we have plus c divided by the quantity of 50 plus t to the 3 halves. Now, initially, okay, the tank has 50 pounds of salt. So we have x at 50 when t is at 0. Okay, so I have 2 times 50 plus 0, so there'll be 100. And I have plus c all over 50 to the 3 halves. And if I take 100 away from 50, so I have negative 50 is equal to c over 50 to the 3 halves. So for c, we're going to have minus 17,677.67. So we're going to have in the rewrite, so we have for x, we have 100 plus 2t minus 17,677.67 all over 50 plus t raised to the 3/2. By the time the tank is full, so you have x equal to 100, and 2 times 150 is going to be 300. 6.25. So whenever the tank is full, you're going to have right at 393.75 pounds of salt.